This is question number 5 from our linear systems review. I have performed the following matrix operations indicated on this matrix. A is equal to 1, 7, 5, 3, 6, 9, 5, 10, 25, augmented with 10, 12, and 100. We first want to interchange the first and second rows, which means the third row is going to stay the same. So let me first write that one out. 5, 10, 25, and 100 after that augmentation. So the first row is going to be the second row of the original function matrix. This would be 3, 6, 9, and 12. And then 1, 7, 5, and 10 would be the second row. For 1/3 of the second row of the original function, matrix, we would have 1, 7, and 5, and 10 still on that first row. The third row is still 5, 10, 25, and 100. But now that second row is going to be 1, 2, 3, and 4. And then finally, for -5 times the first row plus the third row. So let me rewrite the first and second rows of the original matrix. 1, 7, 5, and 10. And 3, 6, 9, and 12. So for that bottom row, if we take -5 times the first row, that makes -5, -35, -25. And after the augmented portion, that would be -50. The third row was 5, 10, 25, and 100. So adding those down, we get a 0, which is what we want in this case. A -25. Another 0, which we did not particularly need, but what are you going to do? And we get a 50. Positive 50. So the bottom row is now 0, -25, 0, and 50. Let me know if you have any questions or concerns. Thank you.